PLC programming spray booth control examples. In this presentation, we're going to look at two different control circuits, which will take into account discrete inputs and outputs, internal bits, and a latch and unlatch feature. Most spray booth applications will have a form of a conveyor system that will pass the object through the spraying booth to allow for even coverage of paint onto the object. In this installation, the spray booth will only energize or start spraying and start coating the object on the conveyor when the object hits the limit switch A. This will cause the limit switch to close. The spray will continue until the object hits limit switch B, causing that limit switch to open. In this situation, we have a normally closed limit switch in the stop portion of the circuit and a normally open limit switch in the start portion of the circuit. Spray SV is an internal bit that will close or go true when spray SV output is on. And this will make for a holding section in our control circuit. The items that are then connected to the PLC are two separate limit switches and a valve that's going to control when the product paint can then spray through the nozzles in the booth. Initially, input B, or the examine if on input for the normally closed limit switch, should be true. As the conveyor brings the object along, it's going to hit limit switch A, which will close limit switch A and cause the A input to go true. This will then cause the spray SV output to energize, turning on the spray, but also making the spray SV internal bit true. The item will go through the paint booth, and as it does, it will release limit switch A, which will cause limit switch A to go back to its false condition, but the spraying will continue because the internal bit is holding the circuit energized through this holding path. The item will continue until it reaches limit switch B, at which point it will cause it to open, making the input go false, and thereby de-energizing the spray SV and the holding contact at the same time. Conveyor then drops the object off a high location and causes a rubble on the floor. This one is a little bit more involved, and it takes into account that we really want efficiency when it comes to spray booth operation. It would be best if the conveyor was somehow controlled by the PLC. That way, the spray booth won't turn on if the conveyor is not operating. This helps to reduce any sort of overspray and mess and wastage of product. In this situation, the operator presses the start push button, and that starts the conveyor. When the object hits limit switch A, the paint spray will start coating the object, and when the object hits limit switch B, the paint spray will stop. The spray operation is not operable if the conveyor is de-energized. And so we can see that interlocking feature here. This is the spray conveyor coil, so this will control the motor. And if we look all the way down here, that is an auxiliary contact on my motor starter. It needs to make this input go true, or else the spray valve will not function. The items that are connected to this would be a stop push button, start push button, two limits, a valve for the paint spray, a conveyor motor, and finally the motor starter itself, which we have limited connections to show the complexity of the system. We're only having the auxiliary normally open contact and the conveyor starter coil connected. First things first, we energize the system. We see the stop push button should cause the stop push button discrete input to go true. We press the start push button in discrete input goes true. Spray conveyor coil goes on, which should then cause the motor to start and for the auxiliary normally open contact to close, which should cause the spray conveyor auxiliary input to go true. At this point, we can release our finger from the start push button, and the object will continue down the conveyor until it hits limit switch A, which will close and cause the input discrete A to go true, causing the spray latch to energize. This will then cause the internal bit spray latch to go true, which will cause my spray valve to energize and for the object to be coated with paint. Once it releases or goes over the limit switch A will go back to open, but remember, this is a latch unlatch feature, which means the latch will stay energized until unlatch is energized. We hit limit switch B, which closes, causing input B to go true, and the unlatch feature to energize, which means that the spray latch should go back to its false condition. Spraying ceases to operate, and again, the conveyor, for some reason, drops the item from a tall height.